Thank you very much, and welcome back to for this remaining session. We would like to continue, but before that, we want to thank very much the Skyward for offer this coffee break for all of us, and thank you a lot. Dr. Nakamura, would you like to continue the session? Thank you.
Thank you, Makio. So we would like to start the sessions about registration, identification, and tracking. So I'd like to invite Mr. Amit Ganjoo, CEO of ANRA Technologies. He is the founder of CEO of ANRA Technologies and has over 20 years of aviation, telecom, and wireless experience in both the federal and the commercial space. He is a licensed pilot and an experimental aircraft builder, following a lifelong passion in aviation. Until December, he acted as the co-chair for FCC's Technical Advisor Council, TAC, for 5G and IoT, which included ground and airborne autonomous vehicles. He was the director of engineering and the principal architect at Ericsson, providing telecom solutions to commercial customers and the federal government, where he was the recipient of the Athena Award. So please, the floor is yours.
Good morning, everyone. I hope everyone can hear me. I'm kind of losing my voice, so if you can't hear me, just ask me to speak up. First of all, I'd like to thank ICAO for giving us the opportunity to come and speak to you guys about what we do. I'll talk a little bit about us for those of you who are not familiar with us. We are a Washington, D.C., a company headquartered in America, Washington, D.C. area, and we have operations in Asia as well. We are almost 2.5, 3 years old now, and very excited to be a part of UTM architecture as well. So our team, overall, the team has over 50 years of comprehensive like robotics, aviation, and communications experience. We are one of the official NASA UTM collaborators, and our platform has pretty much been used in all the TCL tech capability level demonstrations for UTM that were done by NASA at multiple FAA test sites. And we continue to do that work. So going forward, so what's our value proposition? Just continuing on that for a few seconds here. So our main goal as a company was to, when we came, based on my background on DoD and commercial side, we've seen a lot of proprietary and stovepipe solutions. So the goal was to build an open architecture platform. And the analogy I like to use is a cell phone analogy. So I'm sure if I ask how many people in this room use a cell phone, everyone will raise your hands. So if I ask you how does it work, not a lot of people will know how that works. But when you drive around the city, you see a bunch of cell towers around the city. But that's not the whole part of the network. There's something sitting at the base of the tower. There's something sitting in the data center, a core network. Then there are a bunch of other service layer applications like your messaging, tech, internet gateway, billing, provisioning. There are n number of systems. But carriers don't manage all these components individually. They use a platform called an OSS, an operational support system, to manage this end-to-end, orchestrate the whole workflow, their network. That's the paradigm we took for the UTM and the whole overall commercial drone operations. So our platform, we as a company have two platforms that we offer. One is called the Drone OSS, which is our flagship product, and then we have a Drone USS, which is for the traffic management. It's an open platform, so what that means is just like any telecom network, which has different vendors, different providers, but they manage it seamlessly. Same thing, in the drone space, it's not going to be one vendor that magically solves all the problem. It's going to be different vendors specializing in different things, and how do you tie all of them together and orchestrate the whole workflow. So if you look at the next slide, this is our Drone OSS platform, which handles everything from your flight planning, and we are drone agnostic, so that it matters. So what it means is it doesn't matter what drone you're using. You can do everything from flight planning, constraint validation checks, to autonomous execution, remote line of sight and beyond visual line of sight, C2 of the drone using different mechanisms, and I'll touch on that a little bit later, and automatic data collection, data ingestion into the cloud, analytics, and ingestion of the actionable results created from the analytics back into the enterprise systems. That's our drone OSS system. So if you look at the next slide, it kind of highlights some of the features of the platform. So the outside of the standard features like logging and stuff like that, the system was specially purpose-built for handling hundreds, if not thousands, of drones. So it has inherently separation assurance, traffic management, collision avoidance capabilities, and tracking capabilities for a huge fleet of drones. It also has the capability, and again, regulations have to catch up where you have one pilot, multiple drones, and stuff like that. So that's on the commercial side. So this platform, the drone USS, is what most of the folks in this room are probably more interested in. So I'm going to focus most of the effort on this, most of my time talking about this platform. So on this platform, this is our vision of how we see UTM evolving and growing forward. Now, this is a 10,000-foot level view, but if you look at this architecture up there, you have in the center bubble where it says ANRA, that's basically what we are calling the US service suppliers, or USS. I'm going to use that acronym going forward in the rest of the presentation. So that's the USS suppliers. They become a central part of the whole UTM architecture, and the way we envision it, it's going to be a separation between what a government entity controls and what the industry will collaborate and bring to the table, as opposed to the traditional ATM world. So in the industry space, if you look, so you have the USS system in the middle, but it has a bunch of interfaces on the northbound side, on the southbound side. So let's look at the southbound side here. So it's tied into your your operators, their service providers, and the end USS. On the right-hand side, you'll see supplementary data sources. So there are different kind of sources that plug into the system. So you have weather, terrain, C2 performance data, any other stakeholder hazard, terrain, all that, and there can be n number of data sources that come into, or geofences, they come into the system. Then on the northbound side, it exposes interfaces to stakeholders such as ICAO, such as FAA in US, or CAA, or other CAs in different countries, or just general public in some cases, because as stakeholders is not necessarily just government entities. Stakeholders can be general public as well. So it has those interfaces built in. So the system by itself is going to handle the traffic within its realm for the operators that are connected to that system. But like you've heard from multiple speakers yesterday as well, the system is also going to integrate with multiple other USS providers, because it's not going to be one provider that solves all the world's problems. There are going to be a bunch of them, and the information sharing and information exchange is the key. So the system is designed to exchange information between relevant information, keeping, limiting the amount, like was mentioned in the previous, what information you share, whether it's identifiable, non-identifiable, depending on who the stakeholder is. If it's general public, maybe not, but if it's law enforcement, public safety, maybe all the identifiable information as well. And the registration and tracking is going to be handled as part of that workflow. On the left-hand side, what you see is the ANSPs, and only, as opposed to traditional ATM, in this case, only time you'll communicate with the ANSP is when there are non-conformances, when there are alerts, you have flyaways, the issues where ANSP needs to be involved and it's impacting the man traffic, or any other national security issues might come up. So just to give you our perspective, and I know most of the people know what a UTM is, but I wanted to kind of put things in context in terms of our thought process as I move into the registration and the remote ID concept. So what's needed for UTM from our point of view is planning of US operations. That's one of the basic features, I'm sure everyone will agree. Then you have deconfliction of the UTM airspace, whether it's vertical separation, horizontal separation, or time-based separation. And you're going to provide supplementary data to the operators on an ongoing basis during the mission and before, as part of the pre-flight planning. You're also going to bridge the gap between the US operators and the ANSPs. And then other aspects you need to worry about is authentication and authorization. And one of the key important factors that we keep forgetting is, which I heard only a couple of speakers talk about, the life cycle management of when we have the drone in our ecosystem. How do we handle the life cycle management of the safe integration? So let's talk about the remote registration and remote ID first. So I'm going to break it down into 5 different aspects that I'm going to talk about today. So why? How does it help? We're going to talk about managing authority. Which is the authority that regulates the whole remote ID, or is there an authority? We're going to share some concepts that we believe are applicable based on my experience. We're going to talk about the potential IDs that should be used. We're going to talk about identification channels, whether it's networked or local, and then we're going to talk about the security issues. So in terms of why, we all, I think this has been touched on since yesterday a few times. It's required for human stakeholders. It's not required for machines. It's required for human stakeholders. I want to make sure that drone that's flying over my house is supposed to be there. Law enforcement as a general public, I should know it's supposed to be there, but as a law enforcement official, I should know all the details about that mission. I need to be able to make strategic decisions related to mission management, whether it's launching, terminating of an existing mission based on what's happening in the environment. And then the last aspect is ensuring authenticity. How do I know that the drone that it says it's out there is actually the drone it is, that it's supposed to be, and it's not a spoofed, because security becomes a big concern in that case, and it's not a rogue element with a drone flying out there. So let's talk about, am I going too fast? I have a tendency to speak fast. Is this okay for everyone? Thumbs up? Yeah, okay, perfect. So in terms of managing authority, the way, thanks, Christian. I appreciate that. My friend from UAvionics. So managing authority. So there are 2 aspects. This is the concept I believe is key, because now you have all these drones out there. So you need some sort of a centralized mechanism for, I think we kind of concluded, yes, there needs to be a unique identifier which stays with the drone for the life cycle of the drone. Now this identifier needs to be managed in a centralized database. Doesn't matter who handles that database. At an international level, it may be ICAO. At the national level, it may be CA. But eventually, those are going to be federated databases that are going to have to share information from each other. So if we were to walk through the workflow, what you're going to see is you have drone manufacturers who are going, or OEM module manufacturers that are retrofitting, say, existing drones. They're going to have to request remote ID, RID, I'm calling RID in this case, allocation from this database. This database is going to communicate with the issuing authority. Maybe ICAO, maybe XYZ, maybe someone else. The issuing authority is going to say, yes, these remote IDs are available, and they're going to assign these remote IDs. They go back to the drone operator or the OEM, and those modules eventually get into the drones, and then drones are out in the public. So that's one part of the life cycle. Then the next part of the life cycle is, once the drone is out there, you need to have what we call as the color management. What do I mean by that? So once I am a US service supplier, and we are managing an operation, I need to know that the drone that's registered with me and is trying to fly out there is actually the drone. So how do I check that the remote ID it's broadcasting is actually allowed to fly? And it's not a blacklisted or a rogue drone that has been flagged for it's a stolen drone or something like that. That shouldn't be. So I need to do the color management, the blacklist and the whitelist. And then you have a lookup service where the stakeholders can, when they identify an ID, they're going to look up in the system and see the relevant information associated with this ID. So this concept is not foreign. So this is the same way your cell phones work. All your cell phones have a unique identifier called an IMEI. No 2 cell phones in the world share the same IMEI. So we don't have to reinvent the wheel. We leverage the concepts from the industry that already exists there. So we need I'm calling it IMEI-like identifier that can be assigned to each drone, and that can be tracked, and you have its whole life cycle management processes that are already in place, and you can just replicate those. So now let's talk about the identification channels. In terms of the identification channels, there's a lot of debate whether it should be local, whether it should be network-based. We are going to be in disconnected mode where there's no network. What do we do? I don't think there's one solution that fits all. So you need a combination of both networked and local identification systems. So in terms of your local systems, you can look at modifying your existing C2 and data links. And in addition to that, what we firmly believe is you have to look at other low-cost technology and low-power technology that's available out there, like DSRC, which is used for self-driving cars or separation on the highways, and the likes of Bluetooth, especially Class 1 Bluetooth, which has the capability to go up to like 100+ feet. And then on the network side, you can use different kind of network access technologies. Right now, the most predominant one is, say, cellular networks, LTE networks, but it could be SATCOM, but going forward, it's going to be a HETNet, a heterogeneous network, which will be a combination of different technologies, whether it's cellular, whether it's Wi-Fi, whether it's millimeter wave, or the likes. And I think that's what this slide I kind of jumped ahead and talked about this. But one of the things take away from this particular slide is, when you use these low-cost technologies, there are plenty of off-the-shelf sniffers available out there that are continuously sniffing and can sniff and tell you what that identifier is. Now, that identifier has relevant information stored in the database in terms of ICAO, what the drone is, but then the US system will be tracking what the additional operator is, what the mission is, and stuff like that. So based on your access level, you can query that information. But the key is the sniffer is not going to violate any, it uses especially in the low-cost technologies, it's public spectrum. So you're not going to interfere with any regulations or any other, you're not asking for a new chunk of spectrum to use. Network solution, I'm not going to spend too much time on it because a lot of people have talked about it. You can do it over cellular. But the key is you're going to have a heterogeneous network, so you have to account for a lot of different things. You need to account for how do you ensure trust across all these different network access technologies. This is an example I like to talk about, and then I'll wrap up with some security aspects. So in this architecture, we are trying to in this logical, like high-level logical view, what we're trying to show is how a networked and a localized solution can work. So if you look at the top side, that's a typical V2V kind of solution, vehicle to vehicle or vehicle to ground. But we have taken it one step further. It's not just for drones communicating with drones. It's drones communicating to ground and drones communicating with, say, law enforcement vehicles that are equipped with the same technology. So if there's a disaster in an area and a public safety operation is going on, if the drone is coming, they are sharing information with each other, and based on the remote ID, if there's a pop-up TFR, they will know they shouldn't go there. And they can set up a geofence. USS can push a geofence out to the operator so they don't go. And if there's a violation, the first public safety officials know what to do there. And then the other aspect is, do you have the data available via your network channels in the USS, and then your public stakeholders like general public or law enforcement can go to a web portal via a mobile device or their web browser and look up based on the identifier all the information they need. All right, so finally about security, I think security is one of the key things. There are three aspects. I'm not going to go through the details here because I've been told I have 1 minute. So there are three aspects of security. We call it the three pillars. You have to look at the key management, you have to look at the identity management, and you have to look at a denial of service. So in terms of the key management, traditional networks right now use something, most of the times use symmetric keys. So going forward, we have to look at using asymmetric keys. And you have to use hardware roots of trust going forward when you're talking about drones, so that it's harder to spoof, because spoofing is going to become a bigger issue if you're not using hardware roots of trust. And the identity management, you have to look at the identity management for more than just identifying the drone. Based on the identity, you can actually regulate the policy. What if this drone has this ID? Is he allowed to go into this area which traditionally has a TFR, but they have special privileges to go into that area and do some operation. And then finally, it's the denial of service, which everyone is familiar with, but we have to implement different fail-safes. I'll be happy to talk to folks if they have more questions about that, but I can see the 15 minutes are over, so I'm going to wrap up here. Thank you so much.
Thank you, Amit. Yeah, thank you very much for giving us a clear vision of UTM and the remote ID concept, and especially the RID allocation and the color management was interesting. I'm pity that I had to tell him that he only have 1 minute for security issues, even though it's quite important issues. So I hope some questions and discussion time we can discuss about that. So I'd like to present the next speaker, Mr. Jonathon Evans. President of Global UTM Association. Jonathon is a self-proclaimed geeky pilot and 3-time startup co-founders. He was a professional pilot for 18 years and has over 3,000 hours of flight time. He possesses an airline transport pilot license and a commercial and flight instructor rating in airplanes and helicopters. Beginning his career as a UH-60 Black Hawk pilot, Jonathon served as an aircraft and air mission commander for the 236th Jonathon, where 260th Jonathon was selected to fly for the Army's 12th Aviation Battalion, an aviation unit charged with protecting the Washington, D.C. area and flying presidential cabinet members, congressmen, and top Pentagon officials. In both units, he served as a company network administrator, where he built and managed secure computer networks and database during a period when the Army's digital systems were rapidly evolving. He joined the aerial robotic industry with a deep love of aviation history cultivated since boyhood and an unbridled optimism for what's possible as the skies become digital. So please, the floor is yours.
I want to applaud whoever wrote that bio. That was lengthy. Thank you so much for having me here today. Really, it's an honor to get to speak at a podium in the aviation arm of the UN, you know, from a global perspective about aviation's greatest renaissance, as far as I can tell so far. So actually, if you don't mind, I'm going to take a quick picture of all of you, because this is a really cool view for, you know, my Instagram account. Wave, you do something. You know, it's the UN. There. All right, thanks. Yeah, so I have the great pleasure of getting to represent, hopefully, what is a harmonized voice across both the world and across both industry and the regulatory context that this particular industry sits in the regulated commons of the airspace. The Global UTM Association is setting out to answer the call that Amazon called for yesterday, saying we need somebody to write the interoperable blueprint. We need somebody to have industry come together and say, what is the basic language of this aerial internet that we're talking about? What is the TCP/IP for the sky? What is HTTP? And then we'll see this UTM concept emerge. And so that's what the Global UTM Association set out to do. And do I have this? Yes, I do. And this is our membership. We've been in business, if you will, for about 1.5 years now. And now we represent, I believe, over 61 members in and I believe in 16 countries today, with concentrations in the United States, in Europe, and Japan. And so we really are an industry trade association of the folks that are building the pieces and parts of this concept that we keep talking about in harmony of UTM. And that's the first thing that I want to sort of establish from the high view here, is that UTM is a concept. Often people talk about building a UTM system. They talk about when this UTM comes. And I would just ask you to contemplate the question in your head right now: when was the internet built? And did anybody set out to build the internet that we all exist on today as this fabric of our civilization? It's an obvious no. The internet is a concept. Of course, it's built on pieces and parts like routers and switches. There's hardware. There are interoperable protocols so that software can talk across that internet. But I can build a website here in Montreal today that can transmit to Poland, and I can exchange commerce across both those economies on the internet. And that wasn't built by any kind of a central authority. That is a federated, interoperable system. And that's one of the great things about getting to be the Global UTM Association, is that you just heard another great presentation on what is this new animal, what is this new USS or UAC, what is this new digitized, privatized service provider to the sky. Let me ask a question. How many people here are from industry? Raise your hand. How many people here are from the regulatory body? It's almost half and half. Now here's the real question. How many of you are from ANSPs? And did any of you raise your hands on industry or sovereignty? No, you didn't. You waited for a third option, didn't you? Isn't that interesting? The ANSP, I'd encourage you to see as the sort of first iteration of this UTM concept that the regulators of the world first got that they couldn't continue to build this infrastructure from a top-down perspective, that they had to create a service provider. Now, granted, they created a monopolistic service provider that is basically, a state-owned entity, but it is in the market. It is providing real service to users of the airspace. And so when you look at that sort of hybrid entity that's really a sovereign-enabled, free market-based system for service provided to the airspace, I'd encourage you to see further down that spectrum and look at what a digitized, commercialized, and fully regulated and certified service provider looks like in this next age and renaissance of aviation. That's what all of these systems point to. And we have a lot of details to still work out, but we're all calling for the same things. We're all saying that these federated service providers, these folks that can see the airspace and mitigate the risk in it to the standards that are the current standard and better, nothing less. Those folks need an interoperability blueprint that has some basic principles. And one of the things that's also great about being in the Global UTM Association is that we don't have to invent anything. What we've done is we've created a trade association under the best open principles of governance, and we have 3 working groups so far that are working to digest all of the proposals, all of the great tech, all of the great ideas that you've heard in these rooms over these last 2 days. And our working groups strive to distill that information, find the best protocol as advocated for in so many different angles here, and publish it. And agree as an industry, yes, that is the TCP/IP of the sky. That is how we talk to each other. And I'm very proud of our first working group here, the Data Exchange Working Group, because that's what they did in April. They published to Bitbucket, an open repository, an open standard for a flight declaration protocol. A flight declaration protocol is the bit of every UTM architecture that you've looked at. Every single one of these diagrams requires a simple communication bit that says who I am, where I am, and when I am. And then we talk about unpacking the details of that, of registration and authentication of what I am and who I am. But that basic concept of having a polygon that you can put in space that is attributed to an aircraft and a human being that is accountable for that aircraft, that is what we published in April, the first version of a flight declaration protocol, and it is harmonized already with the FAA's implementation of the LANCE system, which is an API call for airspace through a USS, through a commercial provider. And we'll be rolling that out in October in beta, and then in full implementation in February, where the FAA regulator has said there are basically USSs in our airspace now. And Skyward, AirMap, ANR, AGI, many of these companies that are together in a consortium at GUTMA are those USSs. We are the ones that will be giving access to the surface-controlled airspaces as digitally defined in the United States very soon. And our protocol is already in place to say all of these industry providers of that service are going to be doing it in the same language. So those polygons in space, they are seen to each other, and they're known where they overlap. It's a very simple base note, but a fundamental one to this. And so, registration. Did I skip over the first one? I must have, yeah, we did the architecture. Okay. So that's, the second working group is actually data exchange. The first one was an overall architecture working group. And then our third one that is still working right now to get to the first version, the 1.0 version of a living and iterative open standard, is the registration working group, registration and identification. And we formed this one a couple months ago because we recognize this is an important base node as well. And we were thrilled to have ICAO say, we want to carry that mantle. Because when you look at what GUTMA is, we are trying to have an interoperability blueprint for industry to build the kinds of tech that the regulators can certify. It is still regulated airspace. Nobody is trying to take it over. We're just trying to have more sophisticated tools to manage it and to have those regulators understand those tools. And so when ICAO said, you know, our job is to harmonize the protocols from a regulatory perspective across the world, across all of the sovereigns that say, we need to know what an N number is when an airplane lands in our country. We need to know how to do taxiway signs in yellow with black letters in English. And the first protocol of aviation is a language. We chose English. I'm sorry about that in French-speaking Canada, but we chose English. And that is the first interoperability protocol we have of aviation. So now, again, we offer you the notion that what we will do with this registration working group and with ICAO's call for a global registry is we're going to answer that call. And this working group is going to digest all of these proposals and the best tech available in the state of the art. And we are going to provide ICAO a framework that then they can include all of the sovereign signatories in that framework, and we can show you an information age way to solve registration, authentication, and unique identity in all of your countries so that we can recognize that aircraft when it lands in our country. So we're taking up the call and actually applauding ICAO for doing it. This is the most appropriate entity, it seems, to endorse what is not a new invention, just a new direction. And this is clearly the path of intelligence. I'm just sitting there excited, giddy. I feel like I'm sitting here, you know, with a view to history, and a history that as a geeky pilot I always wanted to be part of. And you all are too. And it's amazing to see that we've arrived at a very harmonized solution naturally as an organic, intelligent species. We all know this is the way to do this. So the people in this room can make it happen. And if you're in industry, I encourage you to join GUTMA. Join the conversation, integrate with the standards, and start printing to them, start building to them. We've already put 1.0 out there. Start building to our standards. Watch this industry evolve on that scaffold. And if you are a regulator, we want to invite you to learn these tools, because these are the most sophisticated tools you have to make your jobs easier, more elegant, more efficient, and to make our airspaces safer. Thanks.
Thank you, Jonathon, for presenting us the 3 working group of GUTMA and a very exciting proposal about interoperability blueprint that GUTMA is making. And I'm very looking forward to what's going on from now with the industry's collaborations. So let's go to the third presenter, Mr. Christopher Kucera. He is the Director of Air Operation at Analytical Graphics. In this position, he oversees business development and strategic planning for UAS projects. Mr. Kucera has been with AGI for 14 years and is a commercially rated pilot living in the Washington, D.C. area. So, floor is yours.
Thank you. I'm going to see if this clicker works here. They said it might not work with the PDF. If it doesn't, it is working? Okay, good. So it's always fun to go after Jonathon. One of the founders of UTM, so thank you. And I agree with one of the comments that he made here about, you know, the internet and the timing of the internet. How does it, what's the date of when it came to be? And I think it's about like not sitting around waiting for regulation to happen to move this industry forward, and what are the things that we can do to move forward without regulation. And I'll touch on a bunch of those points, I think, during my presentation. So another thing I wanted to mention is there's a FAA rulemaking committee going on right now about this specific topic that I've been participating in over the past 4 months or so, taking up a lot of time. And a lot of these slides are bringing forth topics that we have discussed at length during those different meetings. So hopefully it will be somewhat thought-provoking material from a bunch of different people that were represented in that FAA ARC. So let me go to the next slide. Just the arrow? Oh, good. Okay. Yep, great, thanks. So just show of hands, how many people have ever heard of AGI before, Analytical Graphics? A few people. Or our software, SDK. SDK is a desktop software that has been used for the past 28 years or so for doing planning and analysis of dynamic systems. So what we do is we look at things like, we started out of the aerospace industry looking at satellites and trying to understand when you could speak through satellites to other things that were moving. So we understand dynamic vehicles, and we look at the payloads on those vehicles and try to assess their impact to mission performance. So the basic question is, how does your position and your orientation affect your mission? And things that might be impacts are things like communication systems, GPS navigation performance, that sort of thing. So why should we register and track vehicles to begin with? This is one of the foremost questions of, that we had to deal with in the ARC, and this is my perspective only, not anything to do with the FAA. And I have a lot of different perspectives on here that maybe aren't shared by the group here. So, the first one is safety. So if you're flying in an area, understanding where other vehicles are in that area. The second one might be from a security perspective. So law enforcement wants to understand who's flying that drone, and then they might go tackle them. The third one is the public. So a drone flying over your backyard, trying to figure out who that drone operator is, and is that something they should be doing or not. And the last one I haven't heard too much about, but it's the financial perspective. So people like to tax things and get money that maybe helps pay for something like UTM. So there's a financial perspective that I think comes into play with registration. And then there's the benefits of it. So this chart tries to capture that. So I think the main theme, though, of all this is that we're trying to remove the anonymity of the operation in all of these different scenarios. And how do we do that? Through registration and tracking. We already track or register lots of different things. So these are, I don't know if everybody can customize license plates in the world, but we do it in the United States. And a picture of my Bonanza that I fly. Last night, I talked a lot with Unifly and Mark about all the different types of IDs that we already have. If you look at airplanes, you got a serial number, you've got the tail number, there's the ICAO code, and then there's the transponder code. So there's different mechanisms, and I'm not an expert on which one to be used, but I do know that if you go to Google and you put in my tail number, you're going to get a lot of information about me, a pilot, that's just open to the world. So I've heard a lot of different discussion about whether that information about a drone pilot should be open as well. And from a pilot perspective, I don't see much difference between somebody flying the drone and somebody flying an aircraft. And it certainly solves a lot of problems within the entire architecture. So again, if the goal is to remove anonymity of the operation, then shouldn't we know who the person is that's flying? But not everything is tracked, right? So do we need to track canoes and bikes and kites and things like that? I think that the issue here is trying to understand what is the threshold for what we want to in place the burden of registration and tracking on. And I don't know that that question's even solved yet. I heard the mention of the term toy earlier in the session before the break. Just saying toy doesn't give you a threshold. You have to define that word, and it's a very, very difficult word to define when you get in a room of 80 different people from different countries that care about the subject. So some toys are very sophisticated, and they're getting more sophisticated. So if you look at these first-person view drones that you can fly basically with a camera at very far distances, some people in the law enforcement don't consider that a toy anymore. So we have to understand the definition of toy to really look at the threshold of what should be tracked and what shouldn't be tracked. So this is just my take on how I think you could imply some rules on the threshold. So the first one might be a regional threshold. So you're operating within a city limits to the air traffic control. Maybe it's within an airspace. And the military's already placed rules that say you really shouldn't be flying in a military base. Maybe they have their own rules for registration and tracking in those areas. Altitude thresholds. You can make an argument that you own your airspace at an inch over the ground, but at what point does that airspace then become something that the FAA or a regulator should control? So I think that there could be an altitude threshold. Maybe it's the tree line for where you do and don't have to comply with some sort of registration tracking requirement. Another one that's important, how far is the operator from the drone? If you talk to law enforcement, they might say that the only reason to have a tracking system is to make sure that they can find the operator. So if you're standing right next to your drone, then that by itself removes anonymity of the operation. So what is the distance that that pushes the bounds there? Is it 300 feet, 400 feet, 1,000 feet? How heavy is a drone? So we've seen this in the registration requirements for the 250 grams. But these things are, like I said, becoming more complex. It's hard to define a weight, I think, class for what you should and shouldn't track anymore. And I think it might turn into more of a capabilities-based kind of threshold. So can this drone fly far from the operator without, and remove that anonymity of the operation? So if you're flying from A to B in an autonomous way, or if you're flying with first-person view capability for a long distance from the operator, then maybe that meets the needs of being able to be tracked. So once you set up these thresholds and you have the rules on how you want to figure out what should be tracked, I think it's really important to think about, back to Jonathon's analogy about the internet and when it got started and how to move this stuff forward, don't wait for regulation. I mean, if there's a regulation coming out of our remote identification rulemaking committee, it could take years for that thing to become a rule. And I think we need to use carrots for compliance, not rules, to get things moving. So it used to be that you would have a carrot on a stick, and you would put it out in front of this mule, and the mule would try to get the carrot, but it could never get the carrot, and so it keeps moving forward. I mean, that's the same kind of concept here, is what can we offer to operators to do something so that they comply with registration and tracking without having to put a rule in place. There's already places where you can't fly today, right? Air traffic control can't fly in Class B airspace without getting a waiver with the FAA. I'm sorry, I'm speaking from a FAA-centric position, but I'm sure this applies to many other countries. What are those places you can't fly in? National parks, around large sporting events, we put temporary flight restrictions up. So if you have these places and you want to start getting compliance, maybe you can do that through allowing people to use things like UTMs and put tracking devices on their drones to get them into compliance faster. So, and the reason that tracking is important is because it enforces that registration component. So I have a picture up in the top right that shows a license plate reader that took a picture of a license plate that is blank. So there's actually probably a license plate there, and it has some sort of a screen over it so that you can't see it from a particular angle because of a filter they've applied. The point is that you could do the same thing for drones, right? If you don't register your drone, but you have a beacon, and the beacon is putting out null information or information that hasn't been registered to you as the operator, that's a problem. But if you're broadcasting, then law enforcement suddenly has an ability to go after you and say, you know, that's something that you need to comply with. So the idea of tracking enforces the idea of registration. So this is a little chart I put together that shows different kind of methods for tracking. A lot of this probably isn't new to you guys, but there are two major buckets, I think, the broadcast and the telemetry that goes through a UTM. So broadcast and UTM, from my perspective, work very well together. I don't think it's an or. I mean, it's an or. I think it's an and kind of solution. So broadcast works in areas where you don't have connectivity. UTM works in a place where you do have connectivity, and together they make up an even better system. So if you're out in the field as a law enforcement officer and you want to figure out who the drone is, you get the ICAO code from the drone or whatever beacon code you're pushing out. If you want additional information on it, you can send that back into the UTM and pull that back from historical archives about how the UTM was used with that same ICAO code in the past. Maybe you find out patterns of behavior that you wouldn't see from the broadcast alone. Other advantages of the UTM are that you don't have to be there all the time to sense where that drone is, right? So if somebody calls a law enforcement on the phone and says, there's a drone flying around my house, I'd like to know who it is. By the time law enforcement gets out there, the drone's probably gone. If he's registered with a UTM, they can quickly look in the system and figure that out. So UTM persists all the time, while broadcast is a very temporary thing, but also has more reliable communications, I would argue. So these are some different tracking options, maybe some benefits of each. Again, I agree with most of the people have said this before, that it's not one to meet all the needs of the different regulatory requirements. I think depending on your type of operation, you may use one or the other. So self-declare, for example, that's basically, you don't need anything tracking-wise or a beacon to meet the intent of a registration requirement. So you basically, with self-declare, just say, I'm flying in this area, and I'm going to do it over the next 20 minutes. And if anybody cares, they'll see that in the UTM. You know, that doesn't work for things like beyond visual line of sight, but it might work for bringing older drones into compliance with registration requirements. And then you have broadcast, LTE, and I haven't heard much mention of satellite, but that would be a good technology to use for some of the beyond visual line of sight pilots. All these different types of tracking systems rely on RF, and that's where our company really comes into play. So we're really interested in the red areas there, that telemetry and broadcast, and it's really about what is the RF coverage that you get out of these technologies. So the top right picture shows our software generating LTE coverage at an altitude and over terrain. Without understanding the RF coverage, you really don't understand the blind spots that you have in your tracking system. So if you don't see a drone coming through the UTM, it may not be that a drone's not there. It may be that you don't have LTE coverage in that area. So my argument here is that let's start thinking more about the infrastructure that we're relying on for the UTM and understand how that works versus just relying on it all the time. We're doing this for a lot of different types of technologies, building different analytical web services for things like GPS navigational accuracy, looking at surveillance systems, radar systems. And last thing I wanted to talk about here is our UTM simulation system. So there's not a lot of things flying today, but we need to test those out in different UTMs. And so with simulation, I think we can look at different types of flight, like doing delivery flights, and how infrastructure support those flights, and how the data that we get back from the onboard sensors meets the needs of the actual system. So I think through simulation, we should start learning about how to hook UTMs together, and I think the whole system can start coming together before we actually go out and fly a lot of vehicles. All right, so in summary, what are the registration identification thresholds the global community can accept? How can the regulators encourage compliance now by offering things like automated authorizations to airspace they currently can't fly in? Analyzing tracking system blind spots, doing more analysis of the infrastructure, and then using simulation to understand how UTM impacts lots of different systems that touch that UTM. So with that, that's all I want to say. Thank you for your time. Appreciate it. Thank you.
Thank you, Christopher. It is very informative that start from flight, it is needed, registration, tracking is needed, and break down into like requirements and some options about tracking method. This process is very informative for persons who are related to make the system of registration in the local. That's very important information. Thank you very much. So I'd like to present the fourth presenter, Mr. Olivier, head of UTM Solutions for Thales, is now representing the French Civil Drones Council, CDC. Olivier has extensive experience in ATM, Air Command and Control System and CESAR program. Olivier is co-leading identification and UTM working groups of the CDC, leading the standardization activities of EuroCAE for UTM and supporting the CESAR JU and the European Commission for defining the European UTM strategy and roadmap. The floor is yours.
Hello everybody, thanks to ICAO to give us this opportunity. Whoa, so many things have been said during the presentations, always difficult to be the last one. But I will try to add a few things on what has been said before. Okay, so maybe to introduce you what is the Civil Drones Council or CDC. It's a body shared by the Executive Director of the French CAA. It's grouping more than 200 members with annual cumulated revenues exceeding 360 billion of euros. And as you can see, this is not only UAV manufacturer, this is industries related to UAV, very big company and smaller company, but it also potential customers for the use of UAVs. It's also include banks, insurance, lawyers, users association, and authorities, transport authorities, homeland authorities, and military authorities. The role of the CDC is to structure the sector in France, organize and maintain dialogue between its members, but also act as a consultation body between authority and industry concerning French and European regulation about UAV. So yes, it's French, but draw your attention on the fact that companies are operating on a worldwide basis. So, that's obvious for most of you, but something I would like to draw your attention on. When we're talking about UAV, we have to think about heterogeneity, which we are not used in aviation. There is so many types of UAVs, so many types of operations, so many types of areas of operations, that one solution fits for all, for registration or other topic, does not make sense, because they are so different, and there will be more and more difference. Another point, where we are today? Well, nowhere. It's quite simple. There is safety concerns, there is security concerns, they are not addressed properly today, so regulation is conservative. That's how it is. So now we have to work together to move step forward. And I would like to remind you something. When we talk about electronic identification, what is the driver? Who is the driver? Is it safety? No. Is it efficiency? No. It's security. That's the key point. It's security. And this is a big difference when we're talking in particular in the ICAO offices. Security does not consider ICAO, neither EASA in Europe, neither ANSPs, nor CAAs. Security calls to sovereignty. And sovereignty does not care about standards or harmonization. It's about protecting the assets of a country and its citizens. We might like it or not. As an industry representative, you can understand that not something that I support, but that's how it is. This is something we have to keep in mind. Registration, first step, what we're talking about. What is important in the perspective of CDC is to work on an international format, or at least local formats that enable international format. Why? Because we want absolutely to avoid that one user registered in France have to register again in Italy and again in Germany and so on and so forth. That's counterproductive. So it's why it's important. However, it has been mentioned that the FAA might take a bit of time to set up regulation for registration and identification in particular. It's coming. It will be into force in France in the coming months. It will be the same in Italy, as the regulations are going to be published in 2018. So it's not tomorrow topic, it's a today topic. This is important, because when we're talking about international format or harmonization, it will not cope with the speed of the state. So one proposal is to say that, in fact, a few bunch of information have to be available between countries, and some of those information remain specific. It could be applicable at a short-term view. A long-term view, yes, for sure, international registration methods and process will be far better for everyone. But we have to keep in mind that it's a 2018 topic. And again, we are very focused on the fact that the format is key to prevent inconsistency between nations and negatively impacting the UAV manufacturers. No doubt about that. But we have to find interim solution while the industry be ready for that. Electronic identification itself. Our proposal is to think about electronic identification in terms of classes. We mentioned that we do not think one size fits all. So what we propose is to have a generic part of the electronic identification, which is about the information to be sent by the UAV systems. It does include the basic information, identification itself, position, altitude, height, and the timestamp. Then there is the optimum information, which are speed vector and angular speed. I will come back to that at the last slide. This is generic. This is type of information that any UAV should be able to send in any case. Then the classes, which will be variable, are more about the way it's going to be sent and the performance it's going to be sent. In terms of performance, it's about reference system, resolution, accuracy, availability, integrity, cybersecurity, data protocol. Top of that, there is 3 potential data sources for this information. The UAV operator application, or the ground control station, the add-on system, the built-in capability of the UAV, and the communication infrastructure. We think that there will be several communication infrastructure that will be able to support the electronic identification. So for those classes, we think that we can work on standards that define class of performance, and that could be used both for UAV manufacturer and the authority. Authority to define the rules according to the risks they see in a given area of a given type of UAVs, and UAV manufacturers to address properly their market. What does it mean? If we take the example of an agriculture precision UAV flying in countryside with no grounded population on a particular risk, Does this UAV need the same level of performance for sending its electronic identification information than a UAV flying in a highly populated urban areas? Maybe not. So this is the idea of class, also to allow the UAV manufacturers to equip the drones in line with the operation for which a drone is put on the market. So avoid over-specification, but also avoid under-specification. We think this is flexible, pragmatic, technology agnostic, and feasible. Very short time frame. Yeah. Yeah, it's okay. Now it's good. So I would like to stop a few seconds on cybersecurity, because it is key. Coming back, it is a security issue. And anything in UTM, this is applicable for cybersecurity, for the electronic identification, sorry, it's about trust, providing trusted systems and trusted services. So cybersecurity is key. What we are talking when we are talking about cybersecurity in the electronic identification concept, in fact, it's quite simple. A lot of software already used. It should be protected against usurpation and repudiation. Communication infrastructure has to be protected against jamming and spoofing. Electronic identifier server and registry should be fortresses and protected against intrusion, because this is privacy data that are in. And cost to be balanced with need and constraint. Then for the last point, we go back to the class approach, saying that we might not need the same level of cybersecurity for all the type of drones or in all the areas. It could be variable. The picture does not show it correctly, I'm sorry, proud where I am, but it does consider network electronic identification and local electronic identification. The principle apply to both. Tracking, well, it has been a surprise to see the word tracking in the ICAO RFI, because for those who are used to aviation, tracking has nothing to do with position. Tracking is very particular, and I go back to the, at one point you have seen in the slide the word optimum, angular speed, vector speed. When we are talking about tracking, it's not receive a position, it's being capable to predict trajectory. From an industry perspective, that's great. Because with, let's say, basic information or positioning information, we can do only simple things. Conformance monitoring, drones flying where it should fly, or accordance regulation. But if we move to tracking approach, we can provide air advanced air situation. So it does open the door for services like conflict detection and resolution, airspace capacity management, and something important, ground support to DAA function. So we have been really pleased to see the word tracking and the ICAO requesting information on that point in their RFI. To conclude, if I can turn my page, yes I can. Regulations and standards should not be technology I will have difficulties with this one. Prescriptive. That's important. It's not the role of regulation or standards to orient the market. Rules are defined by authorities, standards a way to achieve that, but exactly what, it's up to the industry and to the market. Could be a step-by-step approach. We do not need to wait for the perfect solution to move on that topic. One size does not fit all, I already told it. Safety and security come together. Security, electronic identification is security driven, for sure. But it does also support safety. It has been mentioned by my colleagues in the previous presentation, and that's interesting. It's a mutual benefit. If constraints, security constraints are properly addressed, drones will access more easily and efficiently to the airspace, which is what we are all looking for as industry. Standardization in terms of format, protocols, class of performance is urgent. Work has started, which is great, but we need to ensure that it will deliver quickly. I remind you, regulations are coming in 2018. Last point, when talking about solutions, the France has decided to fully recognize private infrastructure like 4G LTE network, and it would be recognized as an infrastructure to provide the electronic identification information. But France is going to deploy a public service, something that you do not have to pay for, most probably which will be relying on 868 bandwidth. That's also something important. Remind, we are talking about security. So if we want to cope with security constraints, we have to ensure that all the users can have access to the infrastructure. So there will be a public service with minimum service and more advanced service through mobile network. But both will be recognized. Thank you.
Thank you very much, Olivier, for presenting us the discussion at the council. I like the word from prescriptive to performance, and I really like the word that flexible, pragmatic, technology, agnostic, and feasible for your approach to the electrical identification. This approach is really needed to bring the innovation and secure the safety and security of the airspace. So let's move on to the Q&A session. I have a couple questions specific to So first we start from specific question, then let's move on to the panel discussions. So one question to Mr. Ganjoo. What kind of information will be exchanged between UAS service supply, and when do that communication include any negotiation like communication for airspace usage?
Can you clarify, like, communication between USS and what? The operator side or the ANSP side?
Is there questioners still here?
Yeah, there's someone there, yes.
I mean, between USS suppliers, between suppliers and suppliers.
And in between suppliers. So that's something that's being the data. So we have, as part of different working groups, we have defined what the format of the messaging and the data will be between the US service suppliers. But the level of data that will be discussed, there are a lot of concerns there, like you probably are aware of. There are privacy concerns, there are competition concerns, like how much do I want to share about my operation if. So, for example, let's say Amazon was running their own USS, and we were the other USS operating in their area. They don't want to tell me where they're delivering the package, right? So that's a confidentiality reason. But we are defining the formats, but safety-critical information will be shared. Like, if my operation is intersecting with your operation, or we are in time or space, our operations are intersecting, this is the flight geography between this time and this time, I'm reserving 100 to 200 for this space. So that kind of information. But in cases there is, say, a flyaway, a lost link, and I've lost control of my drone, and it's venturing into space. In that case, the telemetry data, the trajectory of the drone will be shared as well. So that's one example. It's a long list, but hopefully that gives you a high-level idea.
Can I tag onto that one real quick, and maybe ask you, Chris, to elaborate that, just take it out of the hypothetical and put it into the first 1.0 version of the Flight Declaration Protocol. It actually answers that question, where the PII line is in terms of what we have agreed to as, again, the first version as industry. Chris, can you speak to that a little bit?
Yes, sure. So the concept behind it is that I guess the USS in the terminology we're using right now, but the UTM provider of who owns the customer, maintains the responsibility and holds that customer information, and does not share that directly with a competing USS or UTM provider. If there needs to be a callback through to the originator, there is essentially a tracker URL so that that end user can be put in touch with the originator, protecting that information through the flow.
And again, that's a live protocol that I can tell you is represented, not in open product right now, but on the Skyward platform. And I know Altitude Angel, who Chris represents, also. Both UTM providers or USS providers, all of these members up here are GUTMA members as well. That is a live protocol that actually says which information must be exchanged today when you have two polygons that overlap. So we've answered the question. We're going live with it. Now we can iterate.
Just to add, Jonathan, you have in the slides, I don't know whether you shared the repository where that is all documented.
I don't think we have, but I think that would be super helpful, huh? I don't know it right now. But GUTMA.org, GUTMA.org, and both the architecture and the repository are there. You can get to them. Yeah.
Thank you. Okay, so let's move on to another question. It is maybe for the all. Let's see. So, if the unique global drone ID number is the key for drones travel under different UTM to different countries, what possible smartest way is to design this unique ID system in order to comply with UTMs such as U-Space Cloud in Europe, U-Cloud in China? What do you think? It's all questions.
So I'll take that because that's my pet peeve, because it's basically the concept I used. We have to learn from what has been done before. The whole telecommunications industry was built around so today you can take a cell phone, buy it in US, travel to Asia, Japan, or some other country. Your number is not overlap. You can, as long as the technologies are supported, your device will work on a carrier in Japan, say NTT or stuff like that. So you have to use a standardized mechanism where you have centralized databases which track your whitelist, blacklist. That's the kind of framework. Whether it's IMEI, whatever we call it, but we have to use the same paradigm. That's what I would say.
And to underline the point of what I was saying, that's exactly what we seek to do as GUTMA right now. Like, you probably have all noticed that there are already harmonized solutions in this room for unique identity and authorization and registration. We stopped short of today presenting what that working group is driving towards because they're still considering some of the technological answers. To the point Amit makes, there are perfectly good protocols and systems that work for international harmonized registration and identification and authentication of human users. You've seen them enumerated now many times. So again, what we believe we have to do is decide and print and build things around those protocols. Just choose one and go. And so that's, again, that's what we're doing. By October 30th, you should see our first iteration of what the framework we recommend ICAO use is. And by November 30th, we will have a second version of the data exchange protocol in place that can be some technology that addresses that framework.
Okay, so
Are you waiting on this one? Somebody should represent the DNS ID, I think. Yeah.
No.
okay. So next, that's interesting. It's about international registration database. Considering that drones have a short life cycle, don't you think that an international database might be very unstable and become difficult to manage?
These things have pretty short life cycles.
Yeah, exactly. That's exactly what I was going to say. How often do you change your cell phone?
Yeah.
Okay, so that's other questions are about geofencing, so maybe people use the different way. So we like to accept questions from audience. If you have questions.
Yeah, wonderful presentations, in fact. But I've been, my name is Swaminathan. I'm a technical expert in the Indian delegation. The question is, like, this unmanned aerial system, including aircraft, which is a very small portion, vies for different pies in the airspace. I mean, you could have something totally low level, you could have something which is above the civilian airspace of 460, you can have something in between, and so on and so forth. Is there a way, a concept paper which is being produced by the industry to categorize and see so that there is no conflict, instead of asking for the whole thing and an integration from what is being done today in terms of accommodation? Is there a categorization being looked at, A? And B is, the second question is like, the civil aviation security is probably initiating within the Ministry of Civil Aviation in most of the states. But the Air Force, the military, plays a major role, and I think that could be a huge entry barrier. Is the industry also interacting with people from the military across different nations? Because the sovereign airspace, I think the first entry barrier would be from the military. Thank you.
I'll do the second one first for GUTMA. We've actually struggled with that question at the board about our membership and what our, and Benoit, please back me up if I'm wrong here, but I believe our outcome was that if the military member represents basically an ANSP, if they're a de facto ANSP, which happens in some nations, then we'll accept them basically as a member as we do other ANSPs, but sort of military specific groups, we as GUTMA don't, we're not sort of we're not addressing that, we're addressing the commercial drone industry really. So it's a little bit of, obviously there's a lot of technological overlap there, and a lot of the systems that we would like to standardize on are probably incubated in military systems, but they do arrive to the commercial sector through many other vectors, and we'd be interested in working with them when they're at in that context.
I'll add to that. I think your first question was segregation of the airspace based on levels below 200, above 400, above 4.6. So I don't think there's a consistent consensus across the industry on that. There are some entities that have published white papers. If you Google, you'll find there are some companies that have said, hey, 200 feet and below, we dedicate for this, a corridor for, say, package delivery or something like that. But there isn't, and you guys please correct me if I'm misspeaking, there isn't a standardized agreement on that in the industry right now. And different civil aviation organizations for different states have different takes on it. Like FAA may have a different take on it than CAA or someone else.
I think if you want a sort of a regulatory mantra right now in this age of aviation, this information age of aviation, it's performance-based standards in regulation. That's the sort of, that's where you can set the social intent, the risk mitigation contour that is that social contract. You can still regulate basically without saying how. Right? If you just say that to come into the urban zone, you must now meet a risk mitigation standard that is still at the same 5 9, 6 9, 7 9s that you have set as an intent before. And then the technology must prove that in that space. It must prove that. And that if we can evolve the entire regulatory architecture to something more like that, then you will see the technology, what we all want, to sort of iterate towards the innovations that we're all hoping for, towards that sophistication within the container that regulators set of 5 9s. Right? That should be what we evolve this public-private system to be, I think, in this era. That way you never have to write another TSO. You never have to build another architecture as a regulator, which is hard.
Maybe a few comments. What we're talking about, effectively, the notion of segregation of airspace according to mission. Yes, it's pushed by some companies, but it's a short-term view. At the end, because of the drones, operations are evolving so fast that nobody's capable to really predict in 5 years what would be the type of mission concretely operated by drones. So if tomorrow a drone transporting blood need to go above 300 feet, shall we say, no, your category is below 200 feet. Would not like to be the hospital which is waiting for the blood. That's typical example. That type of barrier might be short-term, but it will not last for a long time. Second comment about the entry barriers. Airspace is not a simple topic. That's how it is. I talk about sovereignty issues. That's the reality of the story. So should we have to talk with transport? Yes. With homeland? Yes. With military? Yes, because military are the one effectively protecting the airspace. It's how it is. It can't be helped. If we want to be successful, we have to address the concern of all of those guys. Coming back to registration, for example, what will be the entity in charge of managing the registry by itself, which contain privacy data, which fell under specific regulation, in particular in Europe? Would it be Transportation Ministry? Maybe not. Maybe it could be the Homeland Ministry. That's the reality of the business. We can't escape from it. We can be again against or pro, but we have to live with it and deal with it and address the concern of all the stakeholders. All stakeholders, obviously including the UAV manufacturer and UAV operator.
I just had two other comments. One of them, the military one, the U.S., I don't think they use ADS-B to remove their anonymity. So I think it's a one-way street, and it's just a matter of having the APIs and allowing them access to where the drones are so they can do their thing. And then...
You're not allowed on the
What's that?
NIPRNet. You're not allowed on the NIPRNet either.
Right, right, yeah. The other one is about the actual altitude threshold, and this is maybe from an infrastructure perspective, but and it frustrates me a little bit that we squash everything down to 400 feet. You know, that's a place where you have a lot of problems with infrastructure. You know, buildings poking up and towers in your way, and things like surveillance systems, radar that wasn't really even designed to work at 400 feet. It's designed to work at 2,000, 3,000 feet. So from if we're talking about a safety perspective, it's better to operate higher. So I hope we can get to a higher altitude where it's safer to operate and not be squashed into that lower altitude forever.
Thank you very much. Do you have other questions? Okay. So thank you very much for wonderful presentations and the discussions. Yes, the speed is very fast, so regulator can make a frame, but industry can give the options to make up to fulfill the performance that the regulator may ask the industry to fulfill. So thank you very much for great inputs from presentators, and thank you very much, audience, and thank you very much for the facilitators for the wonderful half-day sessions. Thank you very much. Thank you. And,
Thank you very much, Dr. Nakamura. That was a crazy. I told you the second half of the game will be very exciting as the first one, right? As you could see, there were a lot of things that were discussed today. You really started to put the nuts and bolts about the registration, identification, and tracking. You saw a lot of reasons, a lot of benefits. One common thing that I received from this session was that new technologies are welcome, but there should be based on existing ones to make it happen more easy and affordable as well. And some other members talk about scalability. It is important to have that to take into account, to have a realistic implementation. And talking about implementation, it's important also to see that states vary from state to state, so you have to have a global harmonization, and what's called ICAO to be the enabler for this. So thank you very much. It was great. So I think it's a well-deserved time for lunch, and again, I want to congratulate and give my thanks to Dr. Nakamura for her great leadership on this one, and the fantastic panelists. Please, another round of applause for them, please. And just a reminder that after we come back from lunch for the start of the plenary session at 2, we're going to do the magic to turn this room into a really plenary room. So please do not leave your personal belongings here. Just take it with you. And when you come back, we'll resume for the plenary. Thank you and enjoy your lunch.